Hello, welcome friends. Me Anila. The topic of my discussion is about limiting reagent. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve numerical related to limiting reagent part 1. In a chemical reaction, the starting material are reactants and the end material is called product. If there are two reactants, one is limiting reagent, other is excess reagent. That means the one that is limiting reagent, it limits the reaction, it is producing less moles of product. On the other hand, excess reagent is in excess. In this video, I will tell you how to solve numerical related to limiting reagent part 1. Example number 1. Calcium carbonate is a salt plus 2HCl hydrochloric acid gives us calcium chloride, a salt plus water plus carbon dioxide, a gas. So this is a chemical reaction. A 25-gram impure sample of calcium carbonate contains 40% purity and reacts with 20 gram HCl. Find the limiting reagent, mass of carbon dioxide produced, excess reagent left. So in this reaction, calcium carbonate salt react with 2HCl hydrochloric acid, strong acid, calcium chloride, salt is formed, water and carbon dioxide is formed. This is a balanced chemical equation. Now, we have 25-gram impure sample of calcium carbonate. Amount of impure sample is given 25 gram. 40% is purity, that means 40% is calcium carbonate and other 60% is an impurity. We have to find the pure calcium carbonate weight. It reacts with 20 gram sample, 20 gram hydrochloric acid, amount of hydrochloric acid is given, amount of calcium carbonate we will calculate. We have to find the limiting reagent, either calcium carbonate or either hydrochloric acid is limiting reagent. Mass of carbon dioxide produced because it is in a product, excess reagent left. The other reagent is excess reagent, we have to find it. Solution. Because there is an impure sample having 25 grams and it is 40%, so we will apply formula. X is the amount of calcium carbonate that is pure into 100 divided by 25 gram is equal to 40%. After solving, the amount of X is calculated to be 10 grams calcium carbonate. Now we have calculated amount of calcium carbonate. Now we will calculate molecular weight of calcium carbonate. 1 is the number of calcium atom into 40 is the atomic weight of calcium, plus 1 is the number of carbon atom into 12 is the atomic weight of carbon, plus 3 is the number of oxygen atom into 16 is the atomic weight of oxygen. After solving, the molecular weight of calcium carbonate is calculated to be 100 gram per mole. Now we will calculate molecular weight of HCl. 1 is the number of hydrogen atom into 1 is the atomic weight of hydrogen, plus 1. 1 is the number of chloride atom into 35.5 is the atomic weight of chlorine. After solving, molecular weight of HCl is calculated to be 36.5 gram per mole. So we have calculated molecular weights of calcium carbonate and hydrochloric acid. Now we will calculate moles of calcium carbonate and moles of hydrochloric acid. Moles of calcium carbonate, the amount we have calculated 10 gram divided by 100 gram per mole is the molecular weight of calcium carbonate. After solving, moles of calcium carbonate is calculated to be 0.1 moles. Moles of HCl 20 gram, the amount of HCl already given in the example earlier. So 20 gram divided by 36.5 gram per mole, which is the molecular weight of hydrochloric acid. After solving, moles of HCl is calculated to be 0.547 moles. So we have calculated moles of calcium carbonate and moles of HCl. Now we have to find which of them is a limiting reagent. If calcium carbonate is limiting reagent, we have to check it. How we will check it? 1 mole calcium carbonate produces 1 mole calcium chloride, as discussed earlier in the example, that 1 mole calcium carbonate produces 1 mole calcium chloride. So 0.1 moles calcium carbonate produces 0.1 mole calcium chloride. Similarly, 1 mole calcium carbonate produces 1 mole carbon dioxide. So 0.1 moles calcium carbonate produces 0.1 moles carbon dioxide. In the same way, if HCl is limiting reagent, in the equation discussed earlier, 2 moles HCl produces 1 mole calcium chloride. So 0.547 moles HCl produces. We will multiply 1 by 0.547 divided by 2, we get 0.2735 moles calcium chloride. 2 moles hydrochloric acid produces 1 mole carbon dioxide. So 0.547 moles HCl produces. We will multiply 1 by 0.547 and divide by 2. We get 0.2735 moles carbon dioxide. Now you can see that we have calculated moles of calcium carbonate, calcium chloride and carbon dioxide from calcium carbonate and from HCl. You can easily say that calcium carbonate is producing less moles of calcium chloride and less moles of carbon dioxide, 0.1 mole, 0.1 mole. On the other hand, HCl is producing greater moles of calcium chloride and carbon dioxide, 0.2735 moles. So, calcium carbonate is producing less moles of product, so it is a limiting reagent, and HCl is in excess, so it is an excess reagent. Since calcium carbonate is producing less moles of product, that is calcium chloride, water and carbon dioxide, so it is a limiting reagent. So we have identified a limiting reagent. Number 2, mass of carbon dioxide produced. We will, for calculation of mass of carbon dioxide produced, we will take that moles of carbon dioxide which are calculated by calcium chloride, that is 0.1 moles into 44 gram per mole. 44 gram per mole is the molecular weight of carbon dioxide. For example, carbon has 12 atomic weight, one oxygen has 16 atomic weight, two oxygen has 32 atomic weight. The total is 44 gram per mole. So mass of carbon dioxide produced is calculated to be 4.4 grams. So we have identified limiting reagent. We have calculated mass of carbon dioxide produced. Now the third one is excess reagent left, that is HCl. Because calcium carbonate is producing less moles of product, so excess reagent is HCl, hydrochloric acid. We have to find how much HCl left after the reaction. Now, we can see that 1 mole calcium carbonate reacts with 2 moles HCl as discussed earlier in the equation. So 0.1 mole calcium carbonate reacts with, we will multiply 0.1 by 2, we get 0.2 moles HCl. So the zero point 0.2 moles HCl are reacted moles of HCl. Now, total HCl moles is equal to 0.547 moles. We have calculated earlier as already given. The amount of HCl is already given and we have calculated total HCl moles 0.547 moles. Now excess HCl moles is equal to total moles minus reacted moles. Total moles we have calculated 0.547 moles minus reacted moles. Recently in the previous slide I have calculated zero point 0.2 moles. After solving, excess HCl moles are calculated to be 0.347 moles. Now mass of excess HCl, we will write 0.347 moles multiplied by 36.5 gram per mole. It is molecular weight of hydrochloric acid. We have calculated this molecular weight earlier. After solving, mass of excess HCl is calculated to be 12.665 grams. So we have identified limiting reagent, mass of carbon dioxide produced, mass of excess HCl. So in a reaction, starting materials are reactants, ending material is product. If two reactants are present, one is limiting, other is excess. Limiting reagent is that one that limits the reaction. In this way, limiting reagent is identified. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.